We're looking at subtracting scientific notation. So I'm not going to go into too much detail about the reasons why this is the process to add or to subtract scientific notation. The process I went over pretty quickly in my adding video. It still has to do with place value overall. If you were to subtract two numbers, you ought to make sure that all the place values in your numbers are lined up. So the ones are over the ones, tens over the tens, hundreds over the hundreds. So when you're dealing with subtracting scientific notation, it is almost an exact replica of adding, but instead of adding, you subtract. So the powers must equal. Before you do anything, adding or subtracting, the powers have to be equal. Number two, we're going to subtract those numbers. And then, of course, keep the power, just like adding. And then three, we're going to check for scientific notation at the end. Whoops, can't spell. So scientific notation. So your answer has to end in scientific notation. Started in scientific notation is going to end in scientific notation. So we'll start with a pretty basic one. 5.8 times 10 to the 10th. And I'm going to subtract 2.7 times 10 to the 10th. So if I look at my three little checkpoints as we go through, step number one is all about having the same powers, which we got. Step number two is to subtract. So I'm going to take 5.8 and I'm going to subtract 2.7. We get 1, we get 3, so 3.1. We keep that same power, 10 to the 10th. And we check to make sure it's in scientific notation. One digit left of the decimal, two decimal places. We have our answer. Of course, they're not all going to be that straightforward. Maybe it's 8.72 times 10 to the 9th. And I want to subtract 2.51 times 10 to the 8th. Not the same power, so step number one is to make them the same power. So this is going to be 10 to the 8th, or this one becomes 10 to the 9th. Once again, you get to choose which power you want to change. It will just influence what the rest of the problem looks like. It will not change the outcome. It is always better to make your power grow larger. Saves you the most time and effort later. So we're going to make this power grow larger, which means my number right here has to go smaller to balance everything out. We're going to take that decimal, one jump to the left, and we get 0.251 for our number. We're now going to subtract 0.251 from 8.72. So we can set this up and do it by hand. Line up the decimal points. And we can subtract by hand. We're also welcome to use a calculator, which is what I'm going to do. 8.72, and I'm going to subtract 0.251. So there's the number that we're going to keep. 8.469 times 10 to the 9th. We're only going to keep two decimal places, so the 9 rounds the 6 up. And our final answer is 8.47 10 to the 9th. If we have powers in the negatives, it's the same process. If I've got 7.82 times 10 to the negative third, and I'm subtracting 5.27 times 10 to the negative fourth, we're going to change one of the powers. The best option is always make the power larger. And then I write the same number because I'm just struggling this morning. So I'm going to make it go from negative 4 to negative 3, which is larger. Causes our number in front to be smaller. And then from here we subtract 7.82 minus 0.527. I'm going to grab my calculator. Then we got 7.82. We subtract 0.527. So there's our number. I'm going to record it, 7.293, if I remember correctly. Yep. Times 10 to the negative third. I'm only going to keep two decimal places, so I'm going to keep these two. So this 3 doesn't have enough power to round us up. We get 7.29 times 10 to the negative third. And this process can be repeated regardless of how large or how small the power of 10 is. They just have to be the same power. It also doesn't matter how far away they are. So if it was like 10 to the 5th and we're subtracting 10 to the 1st, and let's say it's like 6 times 10 to the 5th and we're subtracting 2 times 10 to the 1st, I'm going to change one of these powers. I don't know what it's going to be, but I'm going to change. Well, I'm going to probably change this one to 10 to the 5th. So I'm going to grab this decimal point and I'm going to go 1, 2, 3, 4 spaces to the left. Now my number is 4 powers of 10 smaller. And we're now able to subtract. Why it's so important to make the powers of 10 equal is, again, place value. So it's going to be real quick. 6 times 10 to the 5th is the number 600,000. While 2 times 10 to the 1st is 20. So if I were to subtract 600,000 minus 20, it would look like this. That's why we have to make sure we change that decimal, because now it's 6.000. I think I needed it. No, I did that right. So we need 4 numbers right there. Yeah. And then right here we've got 0.00020. So there's your 600,000, there's your 20. That's what it looks like in scientific notation when we start to subtract. Same process, we've just put the decimals in the same places. That's why we have to change those powers. So make your power go larger, you move your decimal to the left. If you want your power to go smaller, you can move your decimal to the right. Just in the end, whatever your answer is, we want to make sure it's in scientific notation. So after you subtract, say you get the number 37.25 times 10 to the 7th. This is not scientific notation. We have to grab that decimal. It needs to be right here. We just made this problem 10 times smaller, so our power of 10 goes larger. We then only keep 2 decimal places, so that 5 causes the 2 to round up, and this would be the final answer, if you arrived at this part.